Welcome back to another video on my channel, math_exe. Today we're going to look at more perimeter and area problems, and some of these may involve the Pythagorean theorem, well, most of them at least, so just keep in mind that. So you can just go check out my last video where I talked about the Pythagorean theorem. Right, so let's jump into the questions here. Alright, for the first question, it will involve greatly on the Pythagorean theorem. So for part A, we need to determine if a triangle with side lengths 10 centimeters, 24 centimeters, and 26 centimeters is a right angle triangle. And after that, we need to find its area as well. And for part B, we need to find the area of triangle ABC as shown. And then after that, we're going to find the length of AP. Alright, so let's start with part A first. So for a triangle with side lengths 10 centimeters, 24 centimeters, and 26 centimeters, and if you want to find if that triangle is a right angle triangle, you can use the converse of the Pythagorean theorem, is as so. So if you're given a triangle with side lengths A, B, and C, where C is the hypotenuse, that satisfies A squared plus B squared equals C squared, which is the well-known Pythagorean theorem, then this triangle with side lengths A, B, and C is a right angle triangle. So just use that. So first we need to know our sides first. So we know that 26 centimeters is the hypotenuse. So just right. And it doesn't matter where you will consider which is the base and which is the height, because depending on the perspective you're looking at, the base and the height may be different, but the hypotenuse will still stay the same. So using our formula for the Pythagorean theorem, which is A squared, which I'm just going to take 10 centimeters squared, plus B squared, which is 24 centimeters squared, must be equal to 26 centimeters squared. 10 centimeters squared is 100 centimeters squared, and 24 centimeters squared will be 576 centimeters squared, which is equal to 26 squared, which is 676 centimeters squared. And in fact, you can just see here that this is true. And if this is true, then our original assumption that if this is a right angle triangle is true. So this is indeed a right angle triangle. So you can just say yes. And for the area, well, we can just draw this triangle for our guidance. So let's see. So I have 10 centimeters right here, 24 centimeters, and 26. Now we're only going to use 24 centimeters and 10 centimeters because the area of the triangle will be a half times base times height. This is a half times 10 centimeters times 24 centimeters, which is 120 centimeters squared. So that's it for part A. For part B, we need to find the area of this. Well, we know the area of the triangle will be a half times base times height. However, we're only given one of them. We need to find the other, and that's pretty simple. We can just use the Pythagorean theorem. And if you use that, I'll just fast forward to this. You get that this side length will be 12 centimeters. And when you get 12 centimeters, we can just calculate the area. This is a half times base times height. This is a half times 12 centimeters times 9 centimeters equals, well, this will be 54 centimeters squared. Now for the length of AP, it involves looking at the area of the triangle in a different perspective. So we got the area of 54 centimeters squared, where we look at side AC as the base and side AB as the height, or vice versa, depending on the perspective, of course. However, if we're going to look at BC as the base and AP as the height, we are going to theoretically get the same answer, which is 54 centimeters squared. So we can just form an equation in terms of the length AP, which I'm just going to suppose this will be x. So let's see what we have. So this will be a half times the base, which is 15 centimeters, times the height, which is x, is equal to 54 centimeters squared. And then you can just evaluate this real quick and solve for x, which is the unknown, and you'll get that x will be 7.2 centimeters. So that's the length of AP, and therefore we're done for question 1. Let's jump into second question. Alright, so here's question 2. This figure is made out of 2 semicircles and a trapezium, as shown here. And then we need to find the perimeter and area of this figure, taking the approximation of pi to be 22/7. I should probably start with perimeter first. And first we need to probably find this length right here. And we can just do that by using the Pythagorean Theorem by setting up a right angle triangle first. So I'll just draw an imaginary line right here. And notice this length is equal to this length, so just keep that in mind. So the hypotenuse of this right angle triangle is 35 centimeters. And this bit right here is 49 centimeters minus 28 centimeters, which is 21 centimeters. And by the Pythagorean theorem, you can just calculate the length of this thing right here, this imaginary line, and that will be 28 centimeters. So with this, we can just conclude that the length of AB is 28 centimeters. And from here, we can just quickly find the perimeter. So it will be as shown. So the perimeter of the whole thing, which looks like this, I'm just going to draw a mini diagram. Will be the perimeter of this arc, this bit right here, plus 49 centimeters, plus another 28 centimeters, plus the perimeter of this arc right here, which is this bit right here. And we can just calculate those very nicely. So for the perimeter of this arc, we have a half times pi, which I'm just going to take 22/7 times 28 centimeters, plus 49 plus 28 is 77 centimeters, plus a half times 22/7 times 35 centimeters. So notice this and this will cancel, and this will be 4. This and this will cancel, and this will be 5, leaving us with 44 centimeters plus 77 centimeters plus 55 centimeters, which overall will be 176 centimeters. For the area of the figure, we can just find the area of each shape that makes this picture. So that is, I'll just denote this as A of total, which means the total area, which is equal to the area of the semicircle on the left plus the trapezium And finally, the area of the semicircle on the right. The area of the semicircle on the left will be a half times 22 over 7, which is pi, times the radius squared, which is, well, we need to find the radius, which is just a half its diameter, which is 14. So this is 14 squared, plus the area of the trapezium, which is a half times the sum of the parallel lines, which is 49 centimeters and 28 centimeters, and then multiplied by its height, which is 28 centimeters. And then the area of the semicircle on the right will be a half times 22 over 7 times its radius, which is 35 over 2 centimeters. And I'll let you guys continue this step of calculation, and you'll get the area will be 1,867.25 centimeters squared. Alright, so that's it for question number 2. Let's jump into the third one. Alright, for question 3, this figure shows a map of a room with a wall on the center. As shown right here, the area of the floor in the room, which is the green area right there, is 4 meters squared. First, we need to find the value of x in the figure, and for part B, it's pretty straightforward and it's pretty easy to do. So we can somehow form an equation in terms of x relating to the area of the floor. And if we notice that the area of the floor, so I'm just going to denote that as the green box, will be equal to the area of the whole room minus the area of the wall. And when I mean the area of the wall, I mean the surface area, not not just any area, the area that occupies it. So yeah. And the area of the whole room is just the length times breadth, which is 3x meters. Why should we say 3x meters squared? Because that's a unit for area. Minus the area of the blue wall. Well, notice that the wall is designed such that the length right here and the width right here are evenly distributed. So we know that this length right here is just 1 meter, and this length right here will be x over 3 meters. So therefore the area of the wall is x over 3 meters squared. And from the question we know that the area of the floor is 4 meters squared. So you can just cancel out the units of meters squared right here first, because that will be easier. So like combining fractions right here, so we have 9x minus x over 3, and this will be 12 is equal to 8x. That means x is 1.5 meters. So the value of x is 1.5 meters. And for part B, Andy wants to fill the floor of the room with blue carpet. The cost rate of carpeting is $2.5 per meter squared. Find the cost of carpeting the floor, which is pretty simple. So this is going to write part 1 of part B right here, which is just the cost rate multiplied the area of the floor, which is 4 meters squared. Therefore, the cost will be $10. If Andy pays $15, what will be the change? That is pretty simple. It will be $5, which is the amount of payment minus the cost. So that's pretty easy, I guess. So that's question 3. Let's jump into question 4, which is the last question. Alright, for question 4, this is the last one. So this figure shows a park with a pool in the center. We need to find the area of the park unoccupied by the pool first. Alright, so that's pretty simple. We can just know that the area of the green shaded area, which is the area unoccupied by the pool, is just the area of the whole park minus the area of the pool itself. And for the area of the park is made out of a semicircle, a rectangle, and another semicircle. And if you notice, the semicircles are equal in diameter, and therefore we can just combine those both into a, so it'll be 2 times the area of one semicircle. Right, so don't forget we need to minus this with the area of the pool itself. Alright, so let's just compute this. We have 2 times a half times pi times the radius of this, which is a half times 14 meters, which is 7 meters. And the area of the rectangle is 21 meters times 14 meters. And the area of the pool is 7 meters times 3 meters. And since we have pi right here and we're not given the approximation here, we need to be smart here. Since we know that the diameter and also the radius is divisible by 7, we should probably use the approximation of pi to be 22 over 7. And first we can just cancel this first. So we can just pick 22 over 7 because, well, if we simplify this, we notice that this 7 and this 49 will cancel, leaving us with a 7, and that leaves us with a nice integer value. So let you guys continue this. I'll just fast forward this by myself. Alright, after fast forwarding that, you should end up with an answer of 427 meters squared. So that's part A. For part B, John runs around the park with an average speed of 5 meters per second. How long will John take to complete 4 laps around the park? Alright, and first we need to probably calculate the perimeter of this since it involves like running around the park. So the perimeter of the park will be just the perimeter of this bit right here, which is the arc right there, plus 2 times the side length of the rectangle, which is 21 meters, plus yet another perimeter of the square, a semicircle. However, we can just combine those since we know they're identical. So from here we have 2 times a half times, we just use 22 over 7 yet again, since the diameter and the radius are both equal, divisible by 7. The diameter right here will be 14 meters, and this will be 42 meters. So that this will cancel, this and this will cancel, leaving us with 44 meters plus 42 meters, which is 86 meters. Alright, so that's it. So it asks us how long will John take to complete 4 laps. And what I necessarily mean by 4 laps, it means that John runs around the park 4 times, and therefore for the intended distance, you just multiply the perimeter of the park by 4, which will leave us with 344 meters. Okay, and since we know his average speed is 5 meters per second, that means the time needed for John to travel around the park 4 times or complete 4 laps will be 344 meters divided by 5 meters per second. We can just calculate this in decimals, which will be 68.88 seconds, or in fraction form 68.425 seconds, which would take a little bit more than a minute. So that's it. So hopefully you guys enjoyed this video, and please subscribe for more videos, and I'll see you guys in the next one. Goodbye.